Hi, everyone. Welcome to today's webinar. My name is Erin Wozni. I am the Business Development Manager at Softree. With me is one of my colleagues, Matthew Dickey. He is our Training Manager and Resident Webinar Expert. So with that very brief introduction to who you're talking to, let's get started. So here's our plan for today. We are going to be tackling the topic of teaching geometric design with RoadEng in a classroom setting, exploring how you can introduce key principles of road design using an easy-to-use software. Now, the primary audience for today's webinar obviously are educators, but for those of you professionals in the audience, definitely still a lot of applicable content that we're going to be covering. We will be demonstrating a basic workflow for creating a digital terrain model based off of some topo survey data, and then going through the process of creating a geometric road design. So a little bit of context for today's webinar. There are a bunch of reasons why you might not be including a geometric road design software in your curriculum. Commercial tools designed for professionals are usually actually really complicated, expensive, and thus totally inappropriate for classroom use, or perhaps they even require an intensive course of their own to learn. Now, RoadEng was actually built for a different purpose. Originally, we were built for the resource road sector, and as a result, the software itself really focuses on engineering overdrafting, as well as on being easy to use. Now, since our inception back in 1989, we have continued to expand into other civil industries, adding power, functionality for more complicated designs, but really holding true to that easy to use and engineering focus that we started with, making RoadEng pretty ideal actually for the classroom setting. So with that, Matt, are you with me?
Yep, set that as my current screen. All right, well, thanks for the introduction, Erin, and thanks everyone for attending our webinar. Before I start clicking around, just to reiterate that we have a fairly large audience today, and our target audience was educators, but that's not to say that the stuff we cover won't be applicable for folks in industry or across different industries as well. So with that, we'll jump into the software. Now, one thing that if you're not familiar with the software that some folks find different, it's modular. So we're going to work in two modules. We have the terrain module where we're going to bring in our LiDAR data and create our digital terrain model. And then we're going to reference that digital terrain model from location and locations where we're actually going to design our road. So let's pop open terrain. We'll click insert file. Oops. So I've got an LAS file here, and we work with a lot of different data types. We're using a LAS file today. So I'm going to set my projection, and I'm just doing that so it's easy to work with other data if I have other data that's in different projections. If you want to work in local coordinates, it's not an issue. So there's our point cloud brought in. And I'm going to take that point data and create a 3D surface out of it and generate contours. So there we are. There's our contours. See what surface we're dealing with. There's our topo surface. We'll hit File, Save As. So if we wanted to, we could jump right into location now and start designing. Just for a little extra context, I'm going to add a background image. I'm going to pull that off of a web map tile service rather than adding in my own image. If I had my own image, bring it in. If we had our own line work that we wanted to see as well, we could bring that in. So just taking a moment to download. Download's done, stitching it together. And there, we can see where we're at in the world. Now let's minimize this and jump over to location. So I'm going to click File, New File. I'm going to reference that topo surface that I've just created. If I had a preliminary alignment that I wanted to follow to start with, I could. That could be a land XML, it could be a feature in my terrain file, it could be a traverse. In this case, I'm just going to start with a single point. We'll click in our new alignment entirely from scratch. And just to see where we're at, I'm going to refer to that image train that we've downloaded from Bing. And there we are. So we're set up, we're ready to start designing. We've got a couple different options in how we start by tackling this. We could tackle it by clicking in our alignment and then after the fact, making sure our cross-section geometry is appropriate. I'm going to tackle my cross-section geometry first. And here we are. So our cross-section geometry is found in our template editor. The templates themselves don't have a lot of parameters to adjust here. So we can set our crown, we can set some overall behavior for the template. But most of the flexibility in these come from the components. So they're basically a holder of components. So here I've got a rural component, a ditch component, slope component, and we can add all sorts of components to these to get whatever geometry we'd like. They're basically a fillable form, so you don't have to be super proficient to figure out how these work. It's yeah, if I want to change my road width, for example, I can just tabularly change that to whatever we like. I'm happy with my default settings, so I'm going to hit cancel. If we want to make new cross-section geometries to either apply to our entire alignment or apply to sections of our alignment, we can just hit copy, paste as new. So I've pasted that as new just so that's my starting point. Let's assume I want to add in a barrier. So if we have a barrier, we can probably have a steeper fill slope angle. And I'll do that for both sides. But in these default templates that come with the software, there's no barrier component. So for that, I'll click eLibrary. eLibrary is a collection of components broken down into folders. So let's name this RWB for rural width barrier. And we'll click this, and I want to use guardrail. So I'll hit copy here, come up to this, and just paste it into place. So you could paste any one of these. You could remove a roadway component and put in a different roadway component that has a different geometry associated with it. Yeah, it's pretty flexible and pretty easy to use. So I'm going to just paste that in as right, and we'll hit OK. So our cross-section geometry is good, and we can customize that to make it do whatever we'd like. I also forgot to mention, we can test it to see how it behaves without affecting our actual alignment geometry. If we want to look at it in terms of typical cross sections, we've got this four-way view here, or we can look at it specific typical, or we can cycle through to a specific station if we've got an alignment already clicked in. So that's that. I'm going to start now designing my alignment. So I've right-clicked, add edit IP tool. I'll pull my starting IP to where I want to start my realignment. And I'll just add in the tangents as I wish. And we'll see everything's updating in real time as I do this. So we can see our profile is going to add to it as we've added on that leg. Our 3D is updating. And there we are. So if I decide to move this, the topography showing here is going to update as well. And I was happy with where it was, so I'll click undo. So that's adding tangents. The profile behaves much the same way. Now here I've got an exaggerated scale, but I've got my labels turned on so we can see the gradient that we're actually dealing with. You can see our mass hauls being updated as we click through. I'm not going to focus too much on really nailing this yet because we haven't added curves. So let's add curves. So let's add horizontal curves first. And if we want to keep it simple, circular curves, we absolutely can. You don't have to look at all these variables if you're going that route. Simple curves, which gives us a simplified user interface. But if you're doing any kind of highway design or municipal projects, you'll probably want to include spiral curves. You'll probably want to account for your super elevation in that curve. Now we can tabularly do that by hand, or we can turn it to auto. Now what auto's doing here is I've got a super elevation curve table built. So if I have a design speed of 80 kilometers an hour, and if I have a radius of 250, it's adding a 6% super elevation. And then if I change that to 400, it would be a 5.1% super elevation. So we can do that for multiple variables. If you don't want to use our default curve table, you can build your own. And that's just a text file. And you can reference that in. And same can be said for transition lengths, widening, side friction, etc. So we'll hit apply. And there we are. So we've got our transitions, the actual circular portion of the spiral curve, and our transition back. And if we want to change it, we can change it. If we want to change it to a circular curve, we can change it to a circular curve. We can come over here and choose something different for this one if we'd like. If I want it to be a 400 meter radius curve, I've got a super elevation of 5. And we can move that around easily as well. We could change our values or move it wherever we'd like. Now, the vertical curves are similar. I'm going to be dealing with parabolic curves for those instead of circular curves. And there's no super elevation or associated. So with these, we can cycle through to whichever IP we'd like to add a curve. Choose parabolic curve. We can set the K value. If we don't want to set the K value, if we want to define it as length, we can set our length. And if we don't want to set it as length or K value, but want our sight distance to dictate how abrupt that curve is, we can turn it to auto. And auto is going to pull from our sight distance here. So that auto sight distance is generated based off of our driver limitations and vehicle limitations here. Or we could tabularly set that to be a specific value. I'll hit OK. Based off of our design parameters, that's going to be a K value of 47.2. And we'll come over to the next one, go 42. We get a little warning there saying K is too small for desired sight distance. We can change that if we like. We can use that as a talking point a little later in the demonstration. So yeah, here we are. We are adhering to our design constraints. Our road cross-section geometry is appropriate. Our alignment's appropriate. The curves are appropriate, with the exception of that sight distance issue. And then the other big item when designing, oftentimes, well, it's pretty well assumed that you're going to follow the appropriate standards for your design, but the best solution doesn't just adhere to the design parameters, it also adheres to project economics. So for that, we're tracking our material movement in the mass haul diagram, so surplus and deficit. So here we've got a little deficit of material to start off with, then we go through a big cut. We're creating a surplus of material, and that is moved ahead to deal with this large fill. And we can look at that tabularly. So I've got a data table set up here. So these are easy to set up. Set how frequent you want to see the rows and what information you'd like to see in the columns. And we can get a tabular breakdown of our earthworks, or if we've added culverts, we can get a tabular breakdown on our culverts, etc. Now, another neat feature that we have that's unique to us is our design time costing function. So with this, based on our earthworks that we have planned here, we can click recalculate range and see that we're expecting this to cost, and it'll take a moment to think. And we're expecting this as designed to cost $6.5 million. Yeah, so pretty slick. Oh, and one thing that I introduced at the start, that template that we created with our barriers, if we want to apply that somewhere along the route, we absolutely can. We can apply it to both sides or one side, and I'll just do it from station 1105 to 1305, just as an example. So I'll hit assign by range, and 1105 to 1305. And that's going to affect my volumes as well. I'm going to skip ahead to a design that has a couple of alignments in it, and we'll look at another software feature here that's really nice if you're trying to explain concepts to. We've got this one here. I've got my topo surface shown rather than just the contours. So if I wanted to do that in this file, I could 3D options, topo, display triangles, shade, and I'll make it transparent by changing my alpha channel. So there we are. Now, back to this one that's kind of pre-set up. So this one, we've got multiple alignments in the same file. This one's similar to the one that we've started designing. And here we've got that K value of 42 on our crest. Now here, the warning we get is K too small for desired sight distance. Well, let's see how that actually looks from the driver's perspective. So I'll click my 3D view, drive through flyby. I'll click options here. So in this one, I want my target to be at ground, and I only want it to be 15 centimeters tall. My height above path, I'll set that to be 0.108. So that's what my design parameters say. And I can set my distance to target distance to be whatever I like. In this case, I want it to be 130 meters. So I'm just going to jump ahead to station 500. And I'm going to make this a little wider. There. So we can see our target. Now we'll hit play. And we'll see as we go over that crest, we're losing sight of our target. Oh, and that's where you can illustrate the importance of your sight stopping distance and hit apply, make the change, jump right back in, and we can go drive through flyby, options, all good, and start out at 500. And we'll see, we can just barely see it as we go over there because it's right on the requirement. So, and then that costing function that I introduced is also useful here to compare options. So I've costed both of these. They both follow the same design constraints, only this one's going to cost right around $4 million, and this one's going to cost $2.3 million. So, great metric whether you're designing or teaching the importance of earthworks and considering your earthworks for your projects. Yeah, and then just circling back on the start, I mentioned there's all kinds of software functionality that I won't cover today. building off this design time costing, we also have an optimizer. So generating your vertical alignment into a semi-automated process that minimizes the earthworks costs. We've got an optimizer for that. We've also got our multi-plot tool. So similar to paper space from a CAD environment, we can generate our pre-formatted design packages, really streamline the process to get your construction drawings put together really quickly. And we've got other tools such as a culvert editor. We can have more complex templates to account for independent ditch profiles, all sorts of good stuff. But yeah, coming into this, our time was limited and figured this was the most pertinent stuff for teaching highway design. And with that, I think we've got a few questions.
We do. First one for you, Matt. How does RoadEng handle traditional survey data?
All right, perfect. So I don't have traditional survey data for the same example here, but we do handle it quite well. So let's just see if I can pull up a quick example. Traditional survey data being total station or RTK. I've got an example here. So there. Classic ASCII file with your point number, coordinates, and a point code. So when we go to bring that in, we can import it just as the standard coordinate file and play connect the dots if you like. We've also got the ability to set up an IOP. So an IOP is going to let us automate how that's brought in and make sense of the different point codes. So here I've got an IOP set up to read it in, but I'm telling it that our second column is our X coordinate, third column is our Y coordinate, fourth column is our Z coordinate, our point codes, the fifth column. The different options for my point codes are captured here. So if I have a center line, it's going to be brought in as a polyline, and it'll be red, it'll be a break line, triangle, etc. So each point code is going to be treated differently. We can click OK, and then it plays connect the dots for us, and we can generate our surface off of that. So we handle it quite well. And if it's local coordinates, that's fine. If we georeferenced it, I should have added my projection so I could work with the ortho image or any other data I might have, like shape files, etc.
Awesome. Okay, let's move along. I see a ton of questions coming in here. So yes, audience, keep them coming. So the next question is actually a series of 3 questions, I think, about bridges. And I'm just gonna, I'll read it out loud for you, Matt, and then let you break it down into pieces. Okay, so I saw there's a bridge template in the software. Is there any way to insert custom 2D bridge models from a bridge engineer, in brackets, usually CAD, so that it can be printed along with the multi-layout setting? So that's kind of the first question.
Yeah, so if you have like a 2D CAD file, you could bring it in as a train and move it to wherever you like. So I don't have one prep to show this, but we can import all sorts of different formats. So if we just had your bridge line work that you wanted to include in your design, you could bring it in. You can format it however you like, and then you could move it to wherever you like. So feature tools, move. So if we had this on our train or could see where the design was, we could account for it that way. So that's kind of just using it as a graphic or adding it into your train model. Where are we at here? The bridge templates. So if I hit assign by range, you'll see there's a bridge no cut no fill, and all that template in the list is just a center line. There's no earthworks happening. So that just leaves an empty spot where you're not filling into a river, for example. You can create your own cross-section template. You can either do it really complicated way by going customize and building something from scratch. We've also got a bridges folder in here, and you can use the components here to build your deck or whatever you'd like, and you can add that in as a section of road, and that's going to give you a graphic that interacts with your road. So as you move your alignment up and down, that section of bridge is going to move around up and down. Yeah, so.
I think you actually answered the second part of the bridge question there as you tackled that response, which was, can the software insert a 3D model of the bridge? Which you kind of just addressed through our cross-section templates for some types of bridges. And then the last piece of the bridge question, do I have to export the 3D model of the road and combine with the bridge using another software?
So that'll depend how complicated you want to get. If you're really focused on the structural side of things, I would say go that route. We're not really a structural software, so if you're adding like weld details and stuff like that, you'll probably get pretty frustrated going into that level of detail. If you want to go somewhere in between the two, we can do some site grading and site design in terrain as well. So location works great if we're modeling based off of your center line. Now, bridge, if you're modeling your abutments and whatnot, we can do the show your abutment excavations and slope stakes and kind of build those non-linear infrastructure parts and add that in terrain, and we can jump back and forth between the two.
Okay, next question. Moving along here, can you display the underlying triangles for the DTM? It's going back into our terrain module.
So, and actually, since we have the traditional data here now, I'm just going to model that without contours. So there we can see our 3D, where in this example it's pretty easy to see the triangles, but we can add that in our plan as well. So with our model created, we have a surface tab, and we can turn on triangle outlines. So that's a nice tool if, again, with the audience being more education focused, if you're trying to explain what a break line does, well, let's make this not a break line and remodel. And we can see we have those triangles crossing the break line, and then we turn it back to a break line. And there we have it. We've fixed our model. So
Awesome.
Yeah, we can see the.
I was going to say, speaking of crossing break lines, I'm just going to kind of jump ahead in our question list because we've got a question relating to that. So when generating a surface using break lines, if there is a crossing break line between them, we get a warning message. Is there any way to locate that crossing in the plan window? There
is. So I'm just going to, and this is obviously going to be a pretty abrupt error. I'm going from almost a 20-meter difference, but I've got a crossing break line that I've just added. We get that warning. So the issue with this is the software doesn't know which break line to follow. If they share a common point, it's not an issue. But we can find out where that is by clicking right-click, select feature, by property, crossing break lines, and then we can click this guy here, and we can see which feature is crossing. So that's an easy way to find it, and we can look at the individual points as well, or closest point that's crossing it by playing with these two and selecting based off of a property.
Next question, can the software do complex or long roadway analysis?
Yep, so that's something we're really good at. It comes down to the fact that the software is powerful but still light on its feet. So if you're doing like, it's reasonable to do like 50-kilometer lines in a single file. Much beyond that, you might get frustrated with just figuring out the earthworks movement calculations, and it'll lag down, but it's yeah, generally speaking, that's longer than what you can do in most other design softwares. And that's with LiDAR data as well, so it's fairly data heavy example.
Awesome. The next question for you, can we design cross drainage?
Yeah, absolutely. So that's we'll come back to, let's do this example because it's current and it's a little better set up for it. So we can click culvert and okay, so there's our culvert being added. We can change our skew if we'd like. So let's set that skew at, I'm probably gonna get it wrong, but yeah, so we can play with that and play with our gradient. And let's bring that up a little higher. And there we are. And we can also create a data table. Instead of our earthworks, we can have our bill of materials for culverts. You can add as many of those as you'd like. I've got my length auto-calculated based off of my cross-section here. If we want to tabularly set our length, we can. If we want to use a different structure type, we can. If you want to include like a sump and override your ditch at the inlet, we absolutely can. Yeah, so it's meant to be pretty slick.
Okay, why don't we tackle, oh my goodness, there's so many questions. I was gonna say, yeah, one or two more here. I saw a couple that can be lumped together. So first question is, how does RoadEng calculate the costs? And the second question, kind of related, is how can we get the highway cost component?
Okay, so I'm glad that question came up. I skimmed over it. So the cost that I used here is going to be based off of our ground type information. So in this case, I've got one ground type applied. So we can apply, just like I've applied a different template, I can apply different ground types along the length of my road and have different horizons. Now those ground types, we've got our geotechnical parameters, including expansion and compaction factors for each material type, and we can add whatever we like for extra materials if we wish. They also carry handling costs. So here, my overburden's assumed to cost $12 a cubic meter for excavation and $4 a cubic meter for placing and compacting. Whereas if I go up to solid rock, I've told that it's going to be $48 a cubic meter for excavation and $4 a cubic meter for placement and compaction. So that's our excavation and fill costs. Our material movement costs are calculated or defined in here. So these aren't material specific. We'll define a hauling and loading costs. And depending on what our hauling and loading costs, it's going to figure out the optimal break for that category. So free all over all end all. And that movement gets calculated by the software and spits out our number here. Now, add a little more complexity to it, and I'm not going to go into much depth on it. We can also add quality parameters. So if you need a high quality material, the software is going to look at what you have assigned for quality parameters, and the solver is not going to actually use the mass haul diagram. It's going to use our opti haul diagram, which is going to account for balancing your individual materials by individual material with the specific material expansion compaction factor, and yeah, give you a really smart estimate on what's going on here. By default, it's just going to account for your subgrade. If you want to include your surfacing materials, we can by clicking here and telling it what surfacing 1, surfacing 2, surfacing 3, etc. is for the material type that makes it up. So yeah, can talk a lot about that. I'll try and keep it somewhat concise for now. But that's what's going on in the calculation.
Okay, I'm officially going to make this one the last question, and then to the rest of you who have left questions up on our giant list here, we will follow up. Last question, when you change a horizontal PI, can you pick on screen or do you have to type in the coordinates?
Oh, so I was clicking on screen here. So I've just grabbed that, I'll pull it around and click again. So it's a 2-click process. First click unanchors your PI or IP, and the next click is going to anchor it down. Now, if you want to tabularly set those coordinates, you can. So we can click this, and if I want to change that IP location based off coordinates, I can do that here. And if I want to add the next IP, I can do it based off of a COGO. So tell it what angle and how far, and we can add a point afterwards tabularly based off direction and distance. Yeah.
Awesome. So from here, I did mention we were just going to put this up. I will, show our educational licensing, just kind of leave it up here on the screen. And if you have any extra questions, by all means, please reach out to us. You can type them still in that question section and we'll follow up with you directly. You can get in touch with us through our Softree.com website. If you're interested in playing with today's example files, Matt's actually packaged them up. We've got them available through a zip in that handout PDF. So you can open that up, click the links, get the access to the example files. And I'm trying to think if there's anything else I've missed. So that's kind of it for today. We have covered a brief workflow for importing data, setting up a road design, talked a little bit about how you can explain some of the key concepts of teaching geometric design by using an actual geometric design software. And then we do have our educational licensing programs. That's a discounted instructor cost, and then we can provide student licensing for you at no charge. But we'll leave the screen up here a moment, and we look forward to seeing you again at another upcoming webinar.